In this video, you will learn how to multiply both fractions and decimals. So beginning with fractions. When you are multiplying with fractions, you can combine the numerators by multiplying them and combine the denominators by multiplying them as well. And then, if possible, you need to reduce after that. So in math notation, if you had two fractions, a over b times c over d, I would multiply the numerators together to get a times c, and multiply the denominators together to get b times d. So with an actual example, let's say that we had 1 over 2 times 3 over 4. So when I multiply, I do the 1 times 3 on the top to get 3, and then 2 times 4 on the bottom to get 8. So my solution is 3 over 8. And this one does not need to be reduced, but there are cases when you do need to reduce. For example, if you had 2 over 3 times 3 over 4, what I can do is multiply the tops together, so 2 times 3, and the bottoms 3 times 4, so my solution would be 6 over 12. Notice this can reduce. 6 over 12, I can divide the top and the bottom both by 6. 6 divided by 6 is 1, 12 divided by 6 is 2, so this can reduce to be 1 over 2. So that is one way that I can reduce fractions when multiplying. So I could multiply first and then reduce. But the other way of doing this is, instead of multiplying first and then reducing, you can reduce first and then multiply, which will tend to be easier as you get bigger numbers to work with. So explaining number 2, right here we have 2 over 3 times 3 over 4 again. And notice that when I multiply them, 2 times 3 and 3 over 4, I have a 3 on the top and a 3 on the bottom. Okay, anything on the top can combine with anything on the bottom. Or not combine, but divide with anything in the bottom. So see these 3's? We can divide those out. 3 divided by 3 would give me 1 over 1. And then the 2 and the 4 can reduce as well. 2 divided by 4 would become 1 over 2. I divide both by 2. So now I have 1 times 1 on the top and 1 times 2 on the bottom. So my solution is 1 over 2. And so whenever I see a fraction like this, I can imagine this fraction bar extending like that. So now we have 2 and 3 on the top and then 3 and 4 on the bottom. Alright, so when you have multiplication, you can almost imagine this line being extended, and then you can divide anything on the top with anything on the bottom. Here we have negative numbers. Let's say we had negative 4 over 5 times 3 over 8. That negative, doesn't matter where the negative goes. It could go on the side like this, could go with the 4, could go with the 5. Any of those would be the same thing. So let's just say we put it with the 4, just because. And from here, we treat this like any other fraction. So doing that method 2 of solving, we can reduce first and then multiply. So I can imagine this line being extended, so anything on the top can divide with anything on the bottom. So the 4 and the 8 can divide out. Those can both be divided by 4. 4 divided by 4 is 1, 8 divided by 4 is 2. So now I have a negative 1 times 3 on the top and 5 times 2 on the bottom. So that's going to give me a negative 3 over 10. And that's my solution. Another example, we have negative 2 over 9 times 3 over 4. The negative can go with either the 2 or the 9. Let's just put it with the 2. And from here, we can start reducing. So we can imagine this line being extended, and we can divide anything on the top with anything on the bottom. So looking at the 2, that can divide out with the 4. I can divide both by 2, so negative 2 divided by 2 is negative 1, and then 4 divided by 2 is 2. And then the 3 and the 9 can also reduce. I can divide both by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So I have negative 1 times 1 on the top, and then 3 times 2, or 6, on the bottom. So my solution is negative 1 over 6. Now if you have exponents, exponents just mean multiplication. So for example, 2 over 5 squared means you're multiplying 2 over 5 twice. So 2 over 5 times 2 over 5. And with fractions, once again, when you're multiplying, you can multiply the tops together and then multiply the bottoms together. So that's going to give me 4 over 25. Same thing if the exponent is bigger. Let's say we had 2 over 3 to the third power. That means we have 2 over 3 times 2 over 3 times 2 over 3. So I multiply all the 2's together for the top, all the 3's together for the bottom, and that's going to give me 8 over 27. Now if you have negatives with exponents, just be careful that you're getting the sign correct. So looking at the same fraction as before, only now it's a negative 2/5, we now have negative 2/5 times negative 2/5. So negative times negative would give me a positive, so my solution will become a positive number. So the number will still be the same. So we have negative 2 times negative 2, for example, for the top. That becomes a positive 4, and then over 25. But if you have an odd exponent, it's like negative 2 over 3 to the third power, what you want to do is make your answer a negative answer, because what I have is 3 negatives multiplied together. So if you put the negative with the 2, with the numerator, we would have negative 2 times negative 2 times negative 2 for the top, and then 3 times 3 times 3 for the bottom. Well, those 3 negatives on the top would make a negative number, right? 2 negatives make a positive, and then positive times this other negative makes that a negative 8. So I have a negative 8 on the top and then 27 on the bottom. So if the exponent is odd, when you multiply negative numbers together, it's going to be a negative solution. If it's even, so like a second power, fourth power, sixth power, then your solution is going to be a positive number. Now what if you have more than 2 numbers multiplied together, and you can maybe reduce in this case? Well, here's your process. It's really the same as with 2 numbers. When I'm multiplying, I can imagine this line being extended for the fraction bar. So any of these 3 numbers on the top can divide with any of these 3 numbers on the bottom. So looking at the 2 right here on the top, that can divide with the other 2 down there at the bottom. 2 divided by 2 gives me 1 over 1. Looking at the 3's, this 3 and this 3 can divide out. 3 divided by 3 is going to give me 1 over 1. And that's all that can reduce. And so for the numerator, we have 1 times 1 times 1, which is 1. For the bottom, we have 1 times 1 times 4, which is 4. So my solution is 1 over 4. Here is another example. 3 over 8 times 2 over 9 times 4 over 3. So once again, I can imagine this line being extended so that anything on the top can divide with anything on the bottom. So this 2 right here can divide with the 8 down here. I can divide both by 2 to get 1 and 4. Alright, and now this 4 right here that we have on the bottom can divide with the 4 on the top. So 4 divided by 4 would give me 1 over 1. So now we have a 3, 1, 1 on the top, 1, 9, 3 on the bottom. While this 3 on the top can divide with the 3 on the bottom. That's going to divide to give me 1. So now I have 3 1's on the top, and then 1 times 9 times 1 on the bottom. So my solution, when I multiply the top together, is 1 When I multiply the bottoms together, that gives me 9. So my final answer is 1 over 9. Now what if you're multiplying fractions with mixed numbers? For example, 4 2/3 times 6 over 7. What you want to do is convert this mixed number into an improper fraction. So to do that, remember, you can take the 4 times the 3, add that with 2. 4 times 3 plus 2 is 14, and then put that over 3. So this becomes 14 over 3 times 6 over 7. Now from here I can reduce before I multiply. So the 3 and the 6 can divide out, and you can divide both by 3. So 6 divided by 3 is 2, 3 divided by 3 is 1. So I have 2 over 1, and then the 14 and the 7, I can divide those out. So divide both by 7, the 14 becomes a 2, and then 7 divided by 7 is 1. So for the numerator, we have 2 times 2, and the denominator, I have 1 times 1. So that's going to give me 4 over 1, which is equal to 4. Now lastly, we're going to work with multiplying decimals. So for example, if you had 0.042 times 3.17. Now the process for multiplying with decimals, you really can ignore the decimals until the end of the problem. So treat this like a normal multiplication problem. So to get this set up, you have 3.17 times 0.042. So I can ignore the zeros in the front when I multiply. And so I just multiply like normal. I do the 2 times 7, that gives me 14, and then carry the 1. And 2 times 1 is 2, plus 1 is 3, and then 2 times 3 is 6. Now for the 4, I need to put a 0 down here first. 4 times 7 is 28. Carry the 2. This becomes a 2. 4 times 1 plus 2 is 6. And then 4 times 3 is going to give me 12. So then I add these together. I get 4. 11, carry the 1. That's going to be 12. 13, carry the 1. That's 3 and 1. So we multiply like normal. Now at the end, I need to determine where to put the decimal point. So to determine that, I look at each number and see how many digits are past the decimal point. So for 3.17, I have 2 digits past the decimal point. For 0.042, I have 3 digits past the decimal point. So 2 plus 3 would give me 5. So what that means is that the decimal point is starting here. I move it 5 places. So over 1, 2, 3, 4, 5. So my final answer is 0.13314. And now we have 5 digits past the decimal point. So that would be my solution. And that concludes our lesson for today. We will see you next time.